Okay, grade 8. This is 4 questions dealing with proportional reasoning and solving them using 3 different methods. So the first question is your most difficult. We'll come back to it at the end. It's an Olympic question. Your second question says Ava can run 25 meters in 4.1 seconds. How many meters in 1 minute? Question mark. That's missing. And it says use the algebraic method. So the first thing we want to do is we want to kind of set up as distance over time. I want to get my units. It doesn't matter when you're using proportional reasoning. Only if you use the unit rate does it matter. So distance to time, she can run 25 meters in 4.1 seconds. This is what we would call a rate of speed. She runs 25 meters in 4.1 seconds. Not a unit rate because our second term is 4.1 and not 1, so it's a rate of speed. And what we will want to do is we want to say, well, how far can she go in 1 minute? And notice the 1 minute has to go in the bottom where the time unit is. You can't put it in the top. You have to keep it in the correct order that you've established at the start. So because my first rate deals with seconds as the unit, and my second rate is dealing with minutes, I have to change this at the start. So I can't have 1 minute. I actually have to change it to the same units, which is 60 seconds. Okay? And then I'll put X at the top because I don't know how far she can go in 1 minute. So the algebraic method says if you multiply across the equal sign towards your variable, you will create one side of an equation. In this case, I'll create 4.1x is equal to, and then I have to multiply the other way to get the other side of the equation. And I'm going to do 25 times 60, which is, I think, 1,500, but we'll do it anyway. So 25 times 60 is 1,500. So by multiplying this way first, I create this side of my equation. And by multiplying the other way across the equal sign, I create my other side of the equation. And now I just have a basic algebraic equation where I would isolate the variable by dividing both sides by the coefficient, and x will equal whatever 1,500 is divided by 4.1. So 1,500 divided by that 4.1 coefficient equals approximately, and I'll use my approximately sign, 366. So then I have to put my final answer as a sentence. So therefore, I would write down, therefore, Ava can run approximately 366 meters in 1 minute. Okay? That's the answer for that. 366 meters in 1 minute. The third question says $150 for 5 donuts. How much for 6? And it says use the unit rate method. Okay? So the first thing I'm going to do is I want to establish cost per donut. So my first rate is $1.50 for 5 donuts. That's the rate of cost for 5 donuts. And that is going to be proportional to how much for 1. When we use a unit rate, we want to break it down into the cost per 1. In this case, if I divide both the first and second term of my rate by 5, I will get the cost for 1 donut. And $1.50, unfortunately, can be a decimal, but $1.50 divided by 5, oh no, it's not, it's 30 cents, of course, is decimal 30, or 30 cents per donut, right? And if I then break that back into the cost for 6 donuts, I would only have to multiply both by 6, and I would get $1.80 for 6 donuts. And therefore, I can write here, I have space, it is $1.80 for 6 donuts. Okay. And that's using what we call the unit rate method. The trick is to take your rate, break it down into a unit rate, which is, the second term is 1, and then bring it back up to the rate that you're looking for, in this case, 6. And the last question, question 4, says $12 for 120 grams of pine nuts. How much for 30 grams? So we're going to do cost for grams or mass. In this case, it's $12 for 120 grams. How much would it be for 30 grams? Now, in this case here, the reason why I chose this method here, the first method, is 120 divided by 4 is 30. And to keep it proportional, if I divide the first term by 4, I will maintain what we call proportionality, or when we're dealing with fractions, we call it equality. And I would find that it's $3 for 30 grams of pine nuts. Okay? Therefore, it's $3 for 30 grams of pine nuts. Unpause. And our last question, which was our first question that we skipped, it says the men's luge, and this is actually, we looked up the information. The track for men's luge is 1,344 meters long, and some times that were recorded on that track, it took 48 seconds to travel that 1.344 kilometers track. And the question says, what is the speed in kilometers per hour? So since it's asking me for distance and time, I know that distance is going to be my first term, and time is going to be my second term. So for the first one, it's 1,344 meters in 48 seconds. So what I'm going to do here is I'm going to use a unit rate method, or I could actually use anyone. I can use a unit rate. I'm going to do unit rate first. So the first thing I'm going to do is figure out how fast they were going per second. That's the unit rate method. So I'm going to divide the first and second term by 48. And that's going to allow me to see how fast this luger, what a luger, was traveling per second. So 1,344 divided by 48 seconds means he was traveling 28 meters every second. So the distance for every second, he was going 28 meters per second. Now that I have my unit rate, I can figure out what 1 minute was and what 1 hour was. Okay? So in order for me to get 1 minute, I would have to multiply 1 second by 60. And I have to multiply this by 60 as well to get distance per 1 minute. And 28 meters times 60 seconds means he is traveling 1,680 meters per minute. And if I want to get per hour, I would have to multiply that minute by 60 as well. So I'll just keep it there. Multiply that by 60. And he is traveling 100,800 meters per minute. 100,800 meters per minute. Now that might seem like a lot, but 1,000 meters equals 1 kilometer. So 100,800 meters is actually 100.8 kilometers. And therefore, the luger is traveling 100.8 kilometers per hour. Okay? That's the answer using what we would call the unit rate method. But let's take a look at that and see if we can solve it using a different method. If I start with my original rate, if we look at it like this, and I want to know, I know that there are 3,600 seconds in 1 hour, and all I want to know is how long is that distance. I could use the algebraic method. The only thing is, I got to change this first. I got to say, I want to know how many kilometers in 1 hour. Now 1 hour, 1 minute is 60 seconds, and there are 60, so it's really 3,600 seconds in 1 hour. So now that I have my units the same, I could technically use the algebraic method. And I would have 48x equals the product of these two. Take my, oh, that's not right. Take my 1,344 multiplied by 3,600. I would get 4,838,400. And in order to isolate that, I would simply divide both sides by 48. And when I divide that by 48, I get the same answer I got before. 100,800 meters per hour, or 100 kilometers per hour. Okay?